All right, I'm going to do on page 611, we're going to start with number 3 here. The directions say make a net and then find the surface area. All of these problems are going to take a little bit of time to do. You can't just really just rush through them. You're going to draw a net. So in number 3 here, we got a triangular prism. It's really made up of 5 sides. So ultimately, we're going to figure out the area of 5 different things. I kind of drew it down here. So let me scooch up a little bit. And we have a 4 by 4 right triangle. This unknown side here is not 4, so don't assume we're at 4 right here. This is not 4. So we're going to have to figure out what this green line is right here. And we'll figure that out in a moment. I drew a net, as you can see, and it's got 3 rectangles, 2 triangles, which are the base. I highlighted them in yellow. We're going to need to figure out that green line by doing a simple a squared plus b squared is equal to the green line squared. This is 16 plus 16. This, of course, will be the square root of 32, and that would be the green line. So the square root of 32, and I'm going with about 5.66. So that means 5.66. When I throw it in the picture, this is 5.66 here and down here. Okay, so once I have my net, I can see all the parts, and from there you just want to be organized. I'm going to put a little A here in the picture, a B, a C, a D, and an E, and I will figure out the area of each one. So A is a triangle, so it's 1/2 base times height. Whoops. 4 times 4. Section B is a rectangle. Now, all 3 of these rectangles are not all the same. This is base of 4, height of 8. For section C, it is base times height. It is base of 4, height of 8. Section D has a base of 5.66 times height of 8. And section E is a triangle that is similar to section A there. It is a 4 by 4 right triangle. And we would just multiply this out. Saving time here, proof I've got all the answers here. And then to figure out the surface area, just add up all of these 5 parts here, and you will get a surface area of 125.3. This would be inches squared. We got square inches here. Now, all of this here in red off to the side is a way to get organized and show work. Some people can show the work by doing this, and I guess I can do this in blue. If you know triangle A is 8, you can maybe put the answer 8 right there and just circle it. This is an area of 32. This is an area of 32. This is an area of 45.3. And this is kind of another way where visually, if you have your net, you can kind of see what is going on. It's not too hard to decide what is wrong with the work. And if there is a dumb mistake, we can catch exactly where it is. But what we don't want is just for you to write the answer at the back of the book and just say 125.3 and have no work show how you got this answer. Okay, now I'm going to do number 4. They break it into parts, but ultimately what you want to do is just figure out all the areas, lateral area, bases, the surface area of this prism. They do ask us to classify this prism. It is, because the base is a 6-sided figure, we'll call this a hexagonal prism. That means there are 2 hexagons that are congruent and parallel, and everything else is a bunch of rectangles. Now, I drew the picture here, and more importantly, I drew a net, and we're going to do most of the work here on this net here. Okay, they want us to actually figure out the lateral area, which means lateral area is this green section here that don't include the 2 bases. Each side here is 4, so of course if it's a 6-sided figure, it's 4 plus 4 plus 4, 6 times, that's 24. This lateral area is basically height of 10 times 4 times 6, 24. And so this lateral area is 240. Okay. The harder part, and really where all the problems are going to take place, is what is the area of the base, which are these hexagons, which means you know it's going to be this formula, 1/2 apothem times perimeter, but it does take a little bit of time here because we don't know this apothem, which we're going to have to figure out. We know that The sides are 4. We know this will be 2 and 2. And again, this is from earlier work from last chapter. We have to break things apart. From a 6-sided figure, each one of these angles from the middle is 60. And so we're going to split the 60. And I'm going to take this piece right here and enlarge it because I want this apothem. That 60 now is split into 30. This is 60 degrees. This is the 2. And we're going to try to figure out this apothem by using trig. Once we know the apothem number, we can put it all together because we have 2 hexagons plus that green lateral area here. This, of course, is tangent of 60 is equal to opposite apothem over adjacent, which is 2. And real quickly on my calculator, this will be the apothem is 3.46. So the area of one hexagon is going to be 1/2 apothem, 3.46, times the perimeter, and that is 4 times 6, 24. So this is the area of the hexagon. And so this thing will end up being, I'm just using a calculator here, the area of the hexagon is about 41.57. Okay, that's the area of one of these guys, which of course there are 2 of them. And then if you want the entire surface area, add it with the green lateral area, all those rectangles. Okay, and that is number 4. Okay, I'm going to do number 27. I'm going to first read this here. Visualization: the plane region is revolved completely about the given line to sweep out a solid revolution. Describe the solid and find its surface area. So you've got this picture here in red, and we are going to first, for number 27, rotate it around the y-axis. And so, of course, that's the up and down line. And you got to imagine, right now it's in the 2-dimensional world, but you got to imagine this guy is going to go into the 3-dimensional world. And if you do this, and I drew it down here, this guy would just revolve around the y-axis. It would do kind of a loop around the y-axis. And think of it as a 3-dimensional figure now. And this 3-dimensional figure would be a cylinder, where the y-axis would have gone right down the middle of it. Okay, the radius here, hopefully you can figure out the radius. It's right here. You'd have to count it. It looks like it's 4. And so we have a cylinder when we're asked to describe it, and you are going to figure out the surface area. And of course, a cylinder is basically 2 circles and a rectangle with radius of 4. And this height here is right here, and this green is right here. So that looks like it's 2 spaces. So you're going to use the number 2 there. For number 28, you'd rotate that same guy around the x-axis. So take this guy here, and pretty much kind of the same concept. When you rotate around the x-axis, you would make a cylinder this way with a different radius and a different height. And actually the height would go left to right on this particular one, number 28, when you go around the x-axis. Figure out the surface area for both cylinders.